You probably do not need this exact cable generator, but building it is a great way to understand a few very useful geometry nodes ideas. Curves, simulations, velocity, damping, and making boring lines turn into something actually fun. We start super simple, just one vertex extruded into a line. Then I hook both ends of that line to two empties, so now the cable has two control points. That part is not the cool part yet, it is just the base. Now we add geometry nodes. First, the line needs a point in the middle, so we subdivide it once. That middle point is the part that will sag and react later, while the two ends stay attached to the empties. To make the endpoint selection work properly, I convert the mesh into a curve. Then I add set position and move the points down a little. Of course, at first everything moves down, which is not what we want. So we use endpoint selection, invert it with Boolean not, and now only the middle point moves. That gives us the basic hanging shape. Nothing crazy yet, but now the cable has something that can react. The next step is the simulation. Because a static sag is fine, but I want the middle point to wiggle when the empties move. So I add a simulation zone. And this is where Blender does something slightly annoying. Once the geometry enters the simulation, it does not automatically keep reading the live positions from outside. So when I move the empties, the simulated curve does not know what is happening. To fix that, we use sample index. Sample index lets us ask, where is this same point on the live geometry outside the simulation? We feed it the outside geometry, the position, and the index. Now every point inside the simulation can look up its matching real position outside. First, I use that to make the endpoints follow the empties again. I add set position inside the simulation, plug the sampled position into it, and use endpoint selection so only the ends are controlled. Now the ends follow the empties, but the middle point is still free. That is exactly what we need. Now we need the middle point to have motion, so I create a custom vector attribute called vel, short for velocity. At the start, it is 0. Then inside the simulation, I read that velocity with a named attribute and use it as an offset for the middle point. Right now, nothing happens because 0 plus 0 is still beautifully useless. So we need to calculate a force. The idea is simple. We take the live outside position, subtract the current simulated position, and that gives us the direction the cable wants to move. That is basically stiffness. If the middle point is too far from where it should be, this vector pulls it back. Then I scale it down, because without scaling, the cable snaps way too aggressively. Now it has a softer delay. But stiffness alone is not enough. A real cable does not just move to the target and stop like a robot, it has momentum. So we add the previous velocity to the new stiffness force. Now the values build on top of each other and the middle point starts to overshoot. This is where the wiggle starts to feel alive. But if we only add momentum, it will keep bouncing forever, like it has unpaid rent and no plans. So we add damping. I take the old velocity, scale it down, and subtract that from the motion. This removes a bit of energy on every simulation step. Now we have the full spring logic. Stiffness pulls the point back, velocity gives it momentum, damping slowly kills the motion, and we store the new velocity back into the vel attribute so the next frame can use it again. At this point, the cable already reacts nicely. The ends follow the empties, and the middle point has this soft delayed wiggle. Quick thing for the people who actually make money with Blender, or are trying to. I made Tasky because I wanted a simple way to see how much time my projects actually take, how much I earn per hour, and which jobs are even worth it. So if you do client work, freelance projects, or you just want to stop guessing your real hourly rate, check it out. Link is below. Alright, back to the cable, because right now it still looks like a depressed piece of string. First, we smooth the curve. I set the spline type to Bezier, add set handle type, and then use set curve normal with minimum twist. Minimum twist is one of those nodes that sounds boring, but it prevents a lot of ugly curve rotation problems later. Now we can start turning this into an actual cable. The trick is to use curve to mesh. We take our animated curve as the main path, and then we give it a small curve line as the profile. At first, this just creates a weird flat strip, so we add set curve tilt. Set curve tilt rotates the profile along the curve, and instead of giving it one fixed value, we drive it with spline parameter. That means the rotation changes along the length of the cable. Then I add multiply, so we can control how many times the profile twists. Now it starts becoming a spiral, but it still looks wrong because the profile line has 2 points. For this trick, we only want one side of that line, so I use index, compare, and delete geometry to remove 1 point from the profile. Now the shape becomes a clean spiral around the cable. After that, I convert it back into a curve, set the spline type to NURBS, and add set curve normal again to keep the rotation clean. So now we have one nice twisted strand, but one strand is not really a cable yet. We need several of them. So I add a repeat zone. The repeat zone lets us create multiple copies of the same spiral logic. But there is one important detail. Each strand needs a different rotation offset. If they all use the same rotation, they just sit inside each other and nothing useful happens. So we calculate the offset. A full circle is 2 pi. We divide 2 pi by the number of strands. That gives us the spacing between each strand. Then we multiply that spacing by the current iteration. So strand 0 gets no offset. Strand 1 rotates once, strand 2 rotates twice, and so on. Now the strands spread evenly around the cable, and because the twist amount is still separate, we can control how tightly each strand wraps around the main curve. At this point, the procedural part is basically done. We have animated endpoints, we have a simulated middle point, we have stiffness, momentum, and damping, and now we have multiple twisted strands following that motion. The last step is just making it renderable. These are still curves, so I use curve to tube to give them thickness. Then I add a material at the end, and that is the full setup. A cable controlled by 2 empties with a soft simulated sag, a nice wiggle, and procedural twisted strands. And now the main tree officially looks like a crime scene. It works, but editing this later would be actual self-harm, so let's clean it up. First, I take the whole simulation setup and turn it into one custom group called Wiggle. This group takes the curve in, does the simulation, and gives us the animated curve back. Then I expose just 2 controls, stiffness and damping. Stiffness controls how hard the cable pulls back, and damping controls how fast the motion dies. Then I take the whole spiral setup and turn that into another group called Spiral. This one takes the animated curve and generates all the twisted strands. Here I expose amount, which controls how many strands we create, spiral multiplier, which controls how much they twist, and spiral scale, which controls how wide the spiral spreads from the center. Now the main tree is actually usable. We just plug stiffness and damping into Wiggle, then amount, spiral multiplier, and spiral scale into spiral. After that, curve to tube gives the cable thickness, so I also expose its scale input as a final thickness control. In one of the next tutorials, I want to use these cables on a procedural robotic arm made in geometry nodes. So if you want to see that and this tutorial helped you, give the video a like and subscribe. It helps the channel and it tells me to keep making more of these weird procedural machines. And that is it. We started with a simple line, turned it into a simulated procedural cable, cleaned it into reusable groups, and now we have something we can actually use in bigger setups.